The floor is yours, Fabrice.
Yeah. Thanks, Gabor. So I'm going to start with a number. This is like a big number. It's 256 to the power 176. And this number, it takes like 6 lines to actually write it, so it's definitely big. And this is the number of tests that Fabien is going to show to you in the demo, and is going to do live on a piece of code to do cryptography that you could download from the internet. So next slide, what do we propose to do that? Actually, we propose TrustInSoft Analyzer is a tool, technology, which enables you to do this number of tests. So our philosophy at TrustInSoft, so the reason why together with Pascal and Benjamin we created TrustInSoft is we wanted to empower the developers to test and fully master and control the software they have. This is why we bring to you a tool which enables to test all the possible behavior. Whatever happens in the environment of your code, you will be able to make sure that it always behave in a certain manner, or that it will never behave in some other manner which would be bad for you. Next slide. So where do we come from? So we were initially in a research center in France, working in the aeronautic. We today, I would say, we're market proven. That is, we have many, generally kind of big customers as users throughout the world. So that's in Europe, in the US, in Asia as well, in China and in Japan. Today, we are recognized by the NIST. So the NIST is the US federal body. They issued a report to the White House. And in this report, they say, okay, TrustInSoft is able to mathematically guarantee that you do not have like 0 days, such as buffer overflows or stuff like that. This is not present. And why? You remember the big number I've been showing to you at the beginning. We are able to test all the possible behavior of the software on something, in this case, which does some HTTPS encryption. But of course, we have many other kind of usages. We have several, I would say, big names also behind us. Typically, Linux Foundation helped us to develop. I will show you like the first level, like the super easy to use tool we have. And we also are recognized by the RSA conference as one of the most innovative companies. So next slide. So just to, I would say, to tell our story. Initially, we designed in the research center a technology to validate the code, like the most critical code you could find in an airplane, to validate for safety a piece of code in an airplane. So today, we had a growing base in aeronautics, and not only we address cybersecurity, but we also address safety, but we also address cybersecurity. So this is, I would say, where we come from. Then we started to, I would say, tackle new domains, such as typically railway, space, automotive aussi, which is like the picture in the middle. So today we have, for instance, customers such as EasyMile, such as Baidu in China, or it could be ARM also, with just like the microcontroller. So I would say we start from the silicon up to the applicative level, so like the autonomous car, for instance, these kind of things. And last item, and this is something I was very proud of, because not only do we do critical system, which is fine, but we also do consumer electronics. So today we have customers who do phones, who do game. And even though they're not doing any critical device, yet there are so many devices on the field, so many game consoles, so many phones, that indeed making sure that you have a guarantee that never ever a piece of code is going to crash, or that it will always behave in a certain manner, this definitely is extremely useful. Next slide. So I was talking about empowering our developers. So how do we empower our users? I would say we have two axes. First axis, which is the one on the top, is we enable to assess the safety and the security. So we do that because we're able to exhaustively grasp a kind of defect. You don't have to, that is, if you want to have a result like in a few hours, this is possible. And then you're able, if you do put a little more time, to get like an exhaustive behavior. So it could be either just boosting the coverage of your test or reaching the exhaustive behavior as the needs highlighted in the report. And this is something which is really up to you. Second column on the bottom is we enable our customer to save money. We enable our customer to save money by, I would say, being more efficient in the way they do tests. Typically, it's at least a factor of 4. So if it takes you like 4 months to test a piece of code, definitely you can generally achieve the same amount of testing or even bigger in a very smaller time frame. What we also noticed is that our users, generally, they tend to focus on the real issues because TrustInSoft is going to be automatic and automate tests. It leaves more time for the engineers to think about what matters, what makes sense, in which direction they should go. And they can go, if they want, up to a complete specification and prove that the specification is actually met on the software itself. When I say on the software, I mean on the source code itself. Next slide. So I would say we have a three-phase approach. First one, we call that the interpreter or level 1. At this level, we simply replay the existing tests. So you could say it's almost like a sanitizer. The big thing is that this sanitizer is going to be exhaustive with the bugs which are in your existing test. So sometimes a sanitizer might not report an undefined behavior which is present in the test. So you will run your sanitizer, you will run your test, and say, oh, okay, everything is fine. Yet there is an undefined behavior that maybe you will notice later on, which is an issue. So we help you with level 1 to get the most out of your test. Indeed, you invested a lot of time in your test, and we are going to help you making sure that you get the most of the time that you invested in your existing tests. This is level 1. Then level 2 is the analyzer. You remember the big number at the beginning. This is exactly what we are able to do, is to progressively increase the number of tests that you can do so that if you want, you can reach an exhaustive coverage. Together with level 1 and level 2, I would say that's more than 80% of our users. And then the last 20% would be the functional proof, that is proving that indeed a piece of code, a function or a method in C++ is doing exactly what it's supposed to do. Here, it takes a bit more time because somehow you need to specify what you want. We can't guess that. Yet, when you specify it, we can say, okay, what we specified is actually met on the code. Next slide, please. So, in summary, I would say today, what is used by most of our users is making sure that you do not have the undefined behavior. By undefined behavior, which are defined precisely in the C and C++ standard, we mean all the memory access issues like buffer overflow, access out of bound, invalid pointer usage, non-initialized variable, all those kind of bad memory stuff you can't find in C. So we make C and C++ safer. This is what we do. But we do the same also for arithmetic operations. So division by 0, integer, sign overflow, and all these kind of issues. We are also fairly good on the floating point numbers, which is useful for several customers. We have both in aeronautic and in the automotive sector as well. So I see that there are some questions. How is it possible to guarantee the absence of undefined behavior? Okay, so you are going to have a demo. Fortunately, at the end of the demo, it will be better. And you remember that this big number of tests, actually, by making this number of tests, we're able to handle all the possible behavior of the code, whatever happens, like in a buffer which is read or this kind of thing. But I think you have a clear vision after the demo. So this is what you do. Next slide. So if I want to summarize, somehow we package. So why are we so different from the other static analyzer? We package the power of formal methods, and somehow is, I would say, mostly hidden to you, so that you just get the benefits and you don't have the time it takes to actually use the formal method. So we make it easy to use. We make it we enable every developers to benefit from formal methods, either for dynamic analysis or for static analysis. And we do that in an interactive manner where you are able to, at each step, follow what's going on and really be in control, be in the driver's seat, and completely master what's going on in your code. So, next slide. Now it's time for the demo, and you will have a clear vision of how you can do this number of tests, which hopefully will answer the question which has been asked in the chat, where how is it possible to detect everything by doing this number of tests. Thank you for listening to me, and I'll be here for the question right after the demo and Caroline's talk.
Thank you, Fabrice. Fabien, the floor is yours. Don't hesitate to share your screen.
Yes, so everything should be set now. So yes, before trying to prove the absence of undefined behavior for an exhaustive number of combination of inputs that described earlier Fabrice, so we will start trying to prove that for some tests there is no undefined behavior. And so today the playground that we will use is a cryptographic library written by Intel, where this cryptographic library contains different implementation of cryptographic algorithm, and for each of these implementation there is tests that are provided. And the first thing that we want to check is that, for example, if we have a look at the implementation of the CBC cryptographic algorithm and we run the tests that were written, then the result is that the result of the computation is successful. So we are quite confident that the implementation is correct. So what we want to do is to run TrustInSoft Analyzer with the following command line on this exact specific test. So what I have done here is I have written a file that describe all the options necessary to analyze this test. And these options are the files necessary to execute the test, as well as the compilation command that is used to compile this test, and then two options to run the analysis on this test. So here, the interesting thing here is that we executed the test and the result was okay. Yet, when we analyze the same test, there is an out-of-bound access, so there is an undefined behavior. And here, there is no question regarding the results of TrustInSoft Analyzer. This bugs really happens in the code that we are analyzing. So here, the thing that we would like to do is, now that we know that we have this out-of-bound access, we would like to understand it better, because this is a result, but this is a partial result. We would like to really understand why is this out-of-bound access happening and how did this happen. So what we will do is we will run the graphical user interface of the analyzer, and we'll be able to navigate into the analysis to better understand the result of this out-of-bound access. So using the graphical user interface is a great tool because it helps understanding why those undefined behavior happens, and it also helps to find the root cause of the undefined behavior so that we are more able to provide the proper fix for the undefined behavior. So if you have a look here in the upper left side of the graphical user interface, you can see a summary of the analysis where indeed there is a reminding that there is an undefined behavior. And when I click on this provided link, it jumps directly into the function. So it's the copy function of the, if you have a look now at the right-hand side of the graphical user interface. So this undefined behavior happened in the copy function when we call the memcopy function. And here, the analyzer is very precise. So the undefined behavior could happen for the destination pointer or from the source pointer. And here, the analyzer is telling us that this is from the source pointer that there is an out-of-bound access. And now we would like to really understand what's happening. So when we click on each variable here, we can see all the possible values that were computed from the inputs provided by the test of each variable at any source point location. So when I look at the values of from length, I can see that from length is always equal to 16. So if you have a look here in the bottom of the screen, you can see that from length is an unsigned integer where it's always equal to 16. And the from pointer, we can see here that the from pointer can point to many different memory locations. So here, what we would like to ask the analyzer is to reduce the values of from regarding only the value that triggered the undefined behavior. So when I click on this button, you can see now that the result is reduced, and we can see that from points only to the value of the variable encrypted. And if we have a more detailed view of the successions of the values of from, we can see that first, when we call copy, the from pointer is pointing to the offset 16, then 32, then 48, then 64. And when it's equal to the offset 80, then there is an undefined behavior, because if now I have a look at this memory location that is pointed by from, I can see now here that encrypted is an array of 80 characters. So of course, when from is pointing to the offset 80, it is invalid to read from 80 to 80 plus from length minus 1. All right, so now we really understand that, okay, the issue is about the pointer from that is pointing to the last offset of encrypted. So now I will ask the analyzer to take me where the copy function is called, where from is pointing to encrypted. And now I can check that, okay, this comes from the parameter in, and I can also next ask the analyzer, where does the values of in come from? And here the analyzer computes automatically that there is only one place in the source code where in is computed to give this value. And when I select this location, then I can see here that indeed in comes from that different values in this loop. So now, of course, usually from the developer point of view, it helps to know what is the code doing in order to find more faster the issue. And here the issue is that we are iterating on this buffer in using the value outlen. And the value outlen, which is equal to 80, is bigger than it should be. It should be only the possible value that will be valid offset to encrypted. So I can ask the analyzer to show me where does the value of outlen come from. And indeed, I can see here that the length here that is computed, that is 80, should be actually the length of this array, so 64. So now I have everything to understand this issue, which is an out-of-bound access, and I also know where exactly to fix the code in order to remove this undefined behavior. So what I can do now is indeed fix the source code. So I open the file where the issue happened, and I directly go into the line that is the one that we are interested in, and I fix the source code. And now, when I run the analyzer, what I am hoping now is that there will be no other undefined behavior. So here, what we are doing is we are using the inputs provided by the tests. So I will show you it in the graphical user interface. So now that we have fixed this bug, we have the guarantee that there is no undefined behavior. And so what we have done here is that we have verified that if you have a look here on the right-hand side, that for a key with this special value, cryptographic vector with this special value, and some special text and some special ciphertext, when we call the CBC mod encrypt function, there is no undefined behavior, and when we decrypt the function, we have also the expected results. So here we can see that for this special combination of input, we have a coverage of about 88% of functions and about 86% of statements. And what could be interesting now is we would like to increase our confidence into this implementation so that, for example, whatever the input provided and whatever the key used or the vector used, there is no undefined behavior. And to do that, what I have done is I have used the same tests, and I have called a special function where it allows us to consider abstract values, and those abstract values will be any kind of values regarding the type that we modified. So here, you can see here in the center of this function, I have taken the same test where I have added 3 calls to the function thisMakeUnknown. And what it does here is that you can see here that before key was a special key with some specific value, and now the notation here means that we will consider that now this array of 16 characters can contain any kind of unsigned character. So now we are considering the first array that can contain 256 to the power of 16 possible combinations. And we'll do that for key, IV, plaintext, and ciphertext. And the combination of all these generalized value means that what we are trying to prove here is the absence of undefined behavior for all combination of this input, which is 256 to the power of 176. And here the analyzer is able to guarantee that whatever the input provided by the user, there is no undefined behavior. And now what we can have a look at is that we slightly increased the number of coverage for functions and statements. So before we were at 88% of functions, now we are at 96% of functions. And the huge difference is for the first analysis, we were analyzing one combination of inputs, and now we are exhaustively considering all these combination of inputs. And of course, all these results, maybe to summarize the analysis results, can be extracted. So what we can see here in the graphical user interface can be extracted. And for example, here, we have the detailed coverage of all the functions. So most of them are covered to 100%, and a few of them are not very highly covered. And for example, so one of the function is not covered at all. So the compare function, it's because no one is calling this function within the test that is used. And another example is, for example, the check result. So here we can see that indeed, whatever the input, the computed len and the expected len was never different. So, which means that, of course, we will never go into this branch. So this could explain coverage. I think if this is okay, I will maybe answer the questions later, or should we do it now? Yeah, but...
Thank you, Fabien, for the presentation. Yes, so we have a couple of questions. Thank you very much. What I suggest is that we keep them for the end.
Okay.
So be sure that we are going to answer your questions. Thank you. And now it's back to Caroline. Thank you for being with us this morning, and the floor is yours.
Okay, thank you. So Fabrice presented the solution. Fabien demoed one example of the tool capabilities, and what I would like to do on my side is to share some customer use cases illustrating what the primary drivers are for our customers using TrustInSoft Analyzer. Let's start maybe with the one common denominator for all the customers' use cases I am about to share. This common denominator is that all those customers have very demanding requirements or are facing very demanding requirements in terms of code security and or code safety. Those requirements, they may be the result either of the need to comply with specific certification standards for regulated industry, for example, aeronautics. They can be the result of very stringent code validation processes at the enterprise customers of our customers. But they may be as well for our customers who are addressing the consumer market, the risks in terms of brand image of a security flaw, if it's uncovered on the field, in the field, post-production, or the associated risks in terms of field support costs that would, in this case, when the software is on the field, represent millions of euros or dollars of damage. So be it for our customers in regulated industry, be it our customers who are addressing very demanding enterprise customers themselves, or be it for our customers who are addressing the consumer market, the one common point is that all of the examples I'm going to share, they all have very high standards in terms of code security and safety. And this is the starting point. So once we are at this starting point in terms of security and safety requirements, what is the actual value of using TrustInSoft Analyzer for those customers? And across our customer base, we identify potentially three categories are actually 3 ways of classifying those primary drivers and the value that TrustInSoft Analyzer can bring. The first aspect is, I would say, prior to putting the software on the market, prior to putting the product on the market, how we can help and how we help some of our customers improving their operational efficiency in their software development lifecycle. The second aspect is how positioning security and safety as a feature product, and the fact that you can mathematically guarantee security and safety through TrustInSoft Analyzer is the aspect, is a technical point that enables this positioning, is a way to generate revenue opportunities for our customers. And the last aspect and the last category is how TrustInSoft Analyzer can help our customers controlling the financial risks if and when an issue occurs in the field. So let's start with example on the first aspect, which is how to improve operational efficiency in the software development lifecycle. And I will share 2 examples here. I will start with an example in a regulated industry like aeronautics. And I picked this example as, in this case, we could compare the software verification process with and without TrustInSoft Analyzer. So we had actually quantified data. This was or is a project for a communication gateway software. And this is for a tier 1 provider to the aeronautics industry. In this case, TrustInSoft Analyzer is used at what we call stage 1 and stage 2, which is the interpreter mode and the analyzer mode that Fabrice introduced and Fabien demoed. In this context and with this usage, the verification time was reduced from 4 months workload to 1 month's workload, so actually divided by 4. And the important point is that at the same time, the software test coverage was significantly improved because the TrustInSoft Analyzer enabled, as it was demoed, to perform billions of tests on this software. So that's a first example linked to software test for coverage, on how we can improve the efficiency of the software development lifecycle. The other example is in a less regulated industry, and in this case, this is for the software of a setup box. And I picked this example as well, same thing, because in this case, we had metric, because the objective of this customer was actually initially at the first stage to evaluate the capability of the tool to help them to identify complex issues. And in fact, what this customer did is they provided us with a previous version of their software where 2 of their engineers spent 1 full week, so 10 days in total, looking and identifying 1 bug and correcting it. And when they performed the same analysis using TrustInSoft Analyzer and putting it in the TrustInSoft Analyzer at the level 1 as Fabien demoed, it took them 2 hours to identify the bug. So basically, it showed that we enable them to divide, in this case, their effort for bug detection and correction by 40. Okay. So those are 2 examples of the first category is how can we help our customers in their software development lifecycle prior to putting the product on the field. And beyond those aspects of software coverage, help in bugs detection and remediation, of course, the fact that we do not have any false positive is an increase in efficiency as well. The fact that we can test the software as if it was on target are other enablers there helping our customers. If we go to the second category, which is more around how can we help customers generating revenue opportunities in this case, we are at the stage where the software is actually going to the market. And in this case, this example is a tier 1 provider to the rail industry, a very demanding industry in terms of safety in this example. And this customer used the TrustInSoft Analyzer on an automatic embedded software, more than 300,000 lines of code, which is basically software managing inputs coming from multiple sensors. And the objective for this customer was to focus on safety and guarantee mathematically the safety of the critical functions. They were able, by using TIS Analyzer, mostly at the level 2, so the interpreter stage, to guarantee that there was no undefined behavior left in the source code, and therefore that the software would have a deterministic behavior, whatever the inputs, because they could cover 100% of the possible inputs on all critical function. And that this mathematical guarantee, this level of software coverage, was actually positioned as a differentiator for their software versus other competitors for winning this deal. And that was a key element, the fact that they could guarantee the safety of their code with this level of coverage and demonstrate it was a key winning factor. So positioning safety as a product feature is an enabler for market share, but it is an enabler as well in some cases to position your product with a price tag. It is in some cases critical as well for our customers to get on market in the right time to market to grab opportunities, and that we help them to do it with the right level of quality as well. So that's really the second aspect around generating revenue opportunities. The third aspect is once the product is in the field, one of the worry of our customers is to control the financial risk associated with any bugs or flaws detected once it's on the field. And in this case, I illustrated with one of our customers who is a provider to in the smart meter industry. In this case, they're using TrustInSoft Analyzer on a software stack measuring the customer energy consumption. So basically what you have in your cupboard at home. And in this case, they used TrustInSoft Analyzer at level 1 and level 2 with the objective to detect and fix all the critical bugs and increase significantly the coverage of their test. Why is it so important for this customer? Because a part of the software in the smart meters cannot be remotely updated. So if a bug is identified in this critical part, which is measuring the customer energy consumption, then it needs to be updated by a technician going in the field. And this represents, beyond the brand and image effect, the negative brand and image effect, millions of euros or dollars of cost just to correct in the field this issue. So that's really the three aspects. Prior putting a software on the field, how can we help our customers improve their efficiency in their software development and verification process? How we can help our customers, as a second step, position themselves as with security and safety as a key feature and gain market share or a price premium thanks to that, getting at the right time on the market to the right customers. And the third aspect is helping customers controlling the financial risk once the product is in the field. I think we detail this really to share the value which is derived from the TrustInSoft Analyzer tool. And because this is a key element in our process and in our discussion with our customers. We have customers coming from very different fields, be it from aeronautics, regulated industry with certification, to the consumer market devices that Fabrice mentioned earlier. So those industries are drastically different in the way they process. Their software development lifecycle and processes are different. And the drivers from the financial point of view are different. And we need to adapt to all those contexts. And our focus when we start a discussion with a prospect or a customer is to tackle those two aspects. Of course, on the solution side, we want to ensure that our tool is going to bring the right technical performance and is going to integrate well into the IT and the software development processes of our customers. That's one key element. On the other side, we want to make sure that the value we bring fits with the primary business drivers of our customers, and we're actually answering a real issue at the customers. And once we have the two, we can make sure that there is the appropriate return on investment for our customers in using TrustInSoft Analyzer. So I think that concludes our presentation, and I hope it gave some insight into the TrustInSoft solution, how it works, and what we bring. And I think from now, we can probably take some of the questions.
Thank you, Caroline, Fabrice, and Fabien. So we have a certain number of questions. I've seen that Fabrice and Fabien already started to answer some of those, but I suggest that we answer the other ones. For example,
so there's one question about like the what does the mathematical guarantee means? So what the mathematical guarantee means, it's somehow given the algorithmic we use, indeed, it's not possible to have a bug. That's basically what it means. So I would say, which are the fields where you can see that? I would say the first time I saw this, I would say live at some customers, that was in the 90s. In the 90s, people, they started to do that on hardware. Indeed, when you have a chip, you want to make sure that your VHDL code is not going to produce some bad stuff. So you are going to make like a formal verification, generally using stuff like model checking. That was in the 90s. And somehow what we do is we do the same, but we do that on software. So we did that at the beginning of the century with Airbus. So that helped to draft, actually, I would say, the DO 178 in the version C, where actually they define exactly what are the mathematical guarantees. So basically what you should keep in mind is if we do not have a bug in our implementation, indeed, we have a guarantee. And of course, we review carefully what we do to make sure that there is no bug in the software itself. So we have some process to actually qualify the tool themselves. So that's basically my way to answer this question. Fabien, any complement you would like to add?
Yes, I will not go into the details, but the guarantee is given by the word that we call formal methods. Formal methods are mathematical methods which allow us to check the reasoning. And when we do formal methods, we are able, because we are doing some reasoning in a very strict environment, that there is no certain kind of issue. And here the issue that we want to check is the absence of undefined behavior. So just that.
Okay, so I hope this answers the question. So here's another one. from Yanni.
So I wouldn't say it's the general test who cover all the possible undefined behavior. It's, I would say, somehow you could say that we work like a compiler. So a compiler typically, generally, they take advantage of the undefined behavior to optimize the program and change the program. So it's, I would say, if you do something like a compiler, it's possible to exhaustively detect all the undefined behavior. And this is exactly what you do. Then the question would be, for instance, are the tests that I'm generalizing, are they covering all the possible behavior? So generally what is done is we do that like with an architect, or this is done internally at the customer premises, where the developer says, okay, I've been like generalizing those tests. He shows that to the architect, and the architect, he or she says, okay, indeed, you widen the test coverage so much that indeed you widen all the possible values in the environment. So it's a personal judgment, a human judgment, which says indeed what you widen covers all the possible behavior. Fabien, does that matches like somehow experience?
Yes, so I think, so I again just a few additional notes. I can see 3 different questions in the question that you asked. The last question is, how am I able to check that the function is doing what it is supposed to do? And this is what Fabrice described in the first presentation with what we call functional proof. And functional proof is a step of verification where the user formally specify with a formal language what is the behavior of the function. And then there are tools that check that the implementation, the current implementation, satisfy the formal specification. So this part is one part that we did not demonstrate today. And the other 2 questions is how do we cover all undefined behaviors, or at least most of them? It's, again, you could say, so roughly speaking, it's that we implemented all the rules to check undefined behaviors. So, of course, if there were soundness bug in the analyzer, we could miss one undefined behavior, but as Fabrice described, we carefully check the analyzer. So this part that checking all the undefined behaviors is how we implemented the tools to check everything. So for example, access invalid manipulation of pointers, whatever the pointers is pointing to, and this you saw it in the demo. And the generation of tests is more like, there was another question regarding Tessie. It's not like we are, I mean, my way would be, it's not that we are generating tests. It's more like, imagine that you have a test that use random values. Then the difference between random values and what we do is that we consider all the possible values that the random values could generate and into a single analysis. So this is why we are able to guarantee that there is no undefined behavior, because we check that for all the possible values, there is no issue. And simply speaking, what you can do, for example, is picture the verification of the analyzer of, suppose you have a function that is computing the division, then you know that mathematically the division is defined on all values except 0 for the number that is dividing. And the simple check that you have to do is check that 0 is not in the set of the possible values, which would make the division undefined behavior. And this is what is the kind of reasoning of doing the analyzer for all the possible operations that you do on your program. Okay. I hope this helps.
Okay, thank you, Fabien. So I think that we answered most of the questions. I see that someone is writing a new question. So in the meantime, what I would like to say again is that this webinar has been recorded. So if you want to rewatch the demo and the presentations, you are going to get the link in the following days. So stay tuned. And if you, in the meantime, you have other questions that we did not answer in this session, drop us an email and we'll do our best to answer. So we have a last question. And we will stop after this question. Can your results be compared with results from previous runs?
Is this one for me? Yeah, so I briefly talked about it during the demo, explaining that all the results that we can observe in the graphical user interface can be exported. And all these results can be exported into different kind of files, some different format like JSON files or CSV files, etc. And this results is, of course, can be compared with previous runs of previous analysis. So the answer is yes.
Okay, great. Thank you very much, Fabien. So I think that we are going to conclude our session now. Thank you to all the attendees. Thank you to Caroline, Fabrice, and Fabien. Thank you for the questions. And we wish you a very nice day, and stay tuned for the replay link that you're going to receive in the next couple of days. Thank you very much, and we all wish you a very nice day. Thank you and bye-bye.
All right. Take care.
Thank you. Bye.